Okay, now I'm recording. Here we go. Sorry, Hopeful, this one's going to be a little bit short because we're trying to put up a new whiteboard here. So, all right, so they gave me the equation. N2 plus 3F2 goes to 2 NF3. They gave me delta H and delta S, and then they asked me to find delta G on A. So, if I don't know which equation to use, I'm going to get out my equation sheet like Amber has in front of her, and I'm going to find an equation that I can use to find delta G. And what do I find?
Delta H minus T delta S.
There you go. I find that delta G is equal to delta H minus T delta S. Okay? Delta H, they gave to me, is a negative 264 kilojoules per mole. Minus, what temperature am I working with here?
In the standard check?
It's going to be 298. How do I know it's going to be 298?
Because you need to put it in Kelvin. Oh yeah, it says right there.
There you go. Delta G naught at 298. Minus 298 times...
It's delta S, and doesn't it give us that?
delta S, and it gave us that.
At negative 278.
They gave me a negative 278. Look at my units.
Joules per Kelvin, so it would be negative 0.278.
There you go. I've got to change this to kilojoules because that's what my delta H is in.
Good job.
So this becomes of negative 0.278 kilojoules over moles per Kelvin. That's 298 Kelvin, so my Kelvin cancels out. And my delta G should be in kilojoules per mole, which is what I have. I'm going to write it up there. And so I should see that delta G is equal to a negative 181 kilojoules per mole.
See, if all of the
Yes.
responses could be like this, then we could do it.
All right, B says determine the temperature at which the equilibrium constant K for the reaction is equal to 1. Okay, so I want to know the temperature. That's what I'm trying to find, is the temperature when K is equal to 1. So what equation do I see on my paper?
When you use the same one, just give it
Let's look on our equation sheet. What do we see with delta G, with K, with temperature?
negative RT natural log of K.
There you go. I see that delta G, well, is equal to negative RT times the natural log of K. Well, put in K is going to be equal to what? 1. So somebody put in your calculator the natural log of 1. It's 0. So when K is 0, it makes this whole value what? 0. So delta G is equal to what? 0, right? If the natural log of K is equal to 0, anything times 0 is what?
0.
0. So when the natural log, when K is 1, delta G is what? 0. So now I can use this equation. Delta H is equal to delta H minus T delta S, where delta G is what? 0. So now I can rearrange this equation to be delta H is equal to T delta S. Can I not? Yes. Just hand it all to me in one stack. It's good. Thank you very much. No problem. So now, do I know delta H?
Yes.
Do I know delta S? So can I solve for the temperature?
Yes.
Yes. Here. So delta H was a negative 264 is equal to T is what I'm solving for times a negative 0.278. So all I have to do to find my temperature is divide. So do 264 negative divided by 0.278 negative is equal to, and you should get a temperature of 950 Kelvin. All right, you would have gotten 1 point for recognizing that when K is equal to 1, delta G is equal to 0. And then you would have gotten 1 point for your answer. C says calculate. I'm going to erase this. It says calculate the standard enthalpy change delta H, so I'm looking for delta H, that occurs when a 0.256 mole sample of NF3 is formed from N2 and F2 at 1 atmosphere and 298 Kelvin. So they're asking me for delta H when I form a 0.256 moles of NF3. Okay. Well, I know the delta H when I form how many moles of NF3? 2. So I say, well, for every 2 moles of NF3, I get a negative 264 kilojoules per mole. And then I just put that in my calculator, and I should get a negative 33.8 kilojoules. Is everybody with me? Any questions so far? Because we're about to jump to something different for D and E. We're using the same equation, but a little different train of thought. Okay? The enthalpy change in a chemical reaction is the difference between energy absorbed in breaking bonds in the reactants and energy released by the bond formation in the products. How many bonds are formed when 2 molecules of NF3 are produced according to the equation in the box above? So how many bonds are there in 2 NF3 molecules? Okay, who's going to be in the center? Nitrogen. How many fluorines are bonded to it? 3. So if I have 2 of those, how many bonds do I have? 6. Yeah, don't complicate that one. Okay?
I would not think it that way. I would either have really
Yeah, don't complicate it. E says using the information in the box above and the table of average bond enthalpies below to calculate the average enthalpy of the F to F bond. Okay, so let's talk about this. If you remember on the multiple choice question, when we have delta H of formation, okay, then to find delta H, we say delta H is equal to the sum of delta H of the what? Products, right? Minus the sum of delta H of the reactants. You remember that? That's your Big Mama equation. Formation. What was it that guy told y'all? Oh, the F your mama equation. Okay, I know it's terrible. All right. So there's your delta H of formation. Okay, so you do products minus reactants because I remember it like this. What do you form in a reaction? Products. So when I do delta H of formation, my products come first. Okay? These are bond energies. So this is how much energy it takes to make and break a bond. Okay? So what breaks first in a chemical reaction? The reactants, right? We break the bonds of the reactants. So when we're given bond energies, delta H is equal to the sum of delta H of the bond energies of the reactants minus the sum of delta H of the bond energies of the products. That's what you have to remember on the AP exam. Okay? If they give you delta H of formation, products minus reactants. If they give me bond energies, reactants minus products. Everybody got that? Yes? Okay. So, they already told me in the box up there, my equation is N2 plus 3F2 goes to 2NF3. And I already know that the overall delta H is negative 264 kilojoules per mole, right? Yes. Okay. Since we're doing bond energies, I say, okay, so delta H is equal to a negative 264. I'm going to do the bond energy of the what first? The reactants, right? When we do bond energy, we do reactants. So, how many N2 bonds do I have here? N to N bonds. How many of these bonds do I have right here? One, right? It's just N to N, correct? So that means this is going to be 946 plus how many F to F bonds do I have there? 3, right? So that's what I'm looking for. So this is going to be plus 3x, because that's what I'm looking for, is that number right there, right? Okay. Minus, now we're going to do our products. How many N to F bonds do I have there? How many nitrogen to fluorine bonds do I have there? 6, right? So minus 6 times 272. Can you solve for x now? Mm-hmm. Yeah. So I would get a negative 264 is equal to 946 plus 3x minus 1632. And then a negative 264 is equal to negative 686 plus 3x. And then when we get 422 is equal to 3x. And then we would get x is equal to 141 kilojoules per mole. Because I go up here and see what unit they gave it in. So I see what unit I want to give it to back. Makes sense? That's all you're doing. Okay. They would have given you 1 point for recognizing you are only multiplying this by 1, this by 3, and this by 6. And then they would have given you 1 point for your answer. Now, you still could have gotten 1 point for your answer even if you didn't get these right. If you recognized that it was reactants minus products because it was bond energies, even if you didn't have the correct coefficients, they still would have given you credit for your answer. Okay. Everybody got it? Yes? All right, let's go to the second sheet. All right, so the sheet I gave you today is dealing with kinetics. So we're going to do a quick review of kinetics before I start that sheet. Okay, so you don't have this sheet in front of you. You did take this quiz earlier in the year, so you have done it. Okay, but we're just going to use this to review. So if you want to take notes maybe on the side of your paper, just as a reminder of what kinetics is. Now remember, when we deal with kinetics, we're talking about the rate of the reaction. Okay? So I'm not talking about how much product I'm going to get. I'm just talking about how fast is my product going to form. Okay? So that's all we were talking about with reactants. In kinetics, we used a baby K. In equilibrium, we use the big K for our equilibrium constant. In kinetics, this is our baby K is our rate constant. And just like with the big K, it changes for every reaction. Okay, so you don't have a set K for every reaction. It will change. So baby K is your rate constant. We can have 0, first, or second order reactions with kinetics. Okay? So a 0 order reaction is when the concentration changes in the reaction, the rate has no change. Okay? So when I double my concentration, my rate stays the same. When I triple my concentration, my rate stays the same. If I half my concentration, my rate stays the same. So when the concentration has no effect on the rate, we say it's a 0 order reaction. Okay? Yes? If it is a first order reaction, when my concentration changes, my rate does the exact same. So if my concentration doubled, then my rate would what? Double. Or if my concentration tripled, then my rate would triple. Right? Okay. And if it's a second order reaction, then however my concentration changes, my rate does that squared. So if my concentration doubles, my rate is going to quadruple, because 2 squared is what? 4. If my concentration tripled, then my rate would go up by 9, right? Because 3 squared is 9. Does this make sense? Yes? We're good? We're good.
Sorry, I'm trying to coach Nick.
That's okay. All right. So, on this quiz that you took way back when, it asked you to determine the order for each of the reactants NO and H2 from the data given and show your reasoning. So, first we were looking for NO. So when I'm trying to find the order for nitrogen monoxide, I've got to find an experiment where hydrogen stays the same and my nitrogen monoxide changes. Okay? So, what experiment does hydrogen stay the same, nitrogen monoxide changes? What experiment does my hydrogen stay the same and nitrogen monoxide changes? 3 and 4, right?
Yeah.
Hydrogen stayed the same. What did my NO do?
Doubled, so
It doubled.
it's,
And what did my rate do?
it doubled as well. No, it didn't.
It quadrupled. It went up by 4, right?
Yeah,
So-
it's second.
There you go. So we would write it like this. Remember, the order of the reaction is second order with respect to NO. Yes, sir. Huh? I don't, this sheet's not it. This one I'm just going over. All right, now, if we're going to find the order of the reaction with respect to hydrogen, I've got to find where my nitrogen monoxide stays the same and my hydrogen changes. So what experiment would that be?
Where your hydrogen stays the same and your nitrogen?
Nope, nitrogen monoxide stays the same, hydrogen changes.
Right there, 1 and 2.
1 and 2. What does my hydrogen do?
It doubles.
Doubles. What does my rate do?
It doubles.
It doubles. So therefore, I would know that it's first order with respect to hydrogen. We see this?
Yes.
Yes, this is coming back to us. Yes. So then it says write the overall rate law for the reaction. So you just say rate is equal to baby K times the concentration of NO raised to the second. Why did I raise it to the second? Because it's second order. and the concentration of H2, I can either put a 1 there or I can just leave it blank. And I will tell you on the AP exam, on the multiple choice, they just won't put an order there if it's 1. Okay? Now, if it's 0, what do I do with it?
You don't put it in.
I just don't put it, because anything raised to the 0 power is what? 1. It's just 1, so it would cancel out. What if I ask you for the overall order of this reaction?
When you do the digits,
I do 2 plus 1 is equal to 3. So the overall order of the reaction is you just add up all the exponents. Okay. Now, what if they asked me to find the value of the rate constant for the reaction? So I would just pick an experiment, any experiment. I'm going to choose experiment 1. Okay. And I say, well, rate for that experiment is... It's not working. Come on. I think we're froze up. Huh?
No more class.
Oh no, this came out. We're not froze up. We're just not. Oh no, it didn't come out. It's there. It's not working. There we go. All right, so we say rate, or we don't. We do say. All right, sorry, Hopewell, we're having technical difficulties. All right, so rate is for the first one is 1.8 times 10 to the negative 4. And they gave me molarity per minute is my unit. Is equal to K, because that's what I'm solving for. I don't know what that is. Times, what concentration did they give me for experiment 1 for NO? 0.006. And I'm going to square that. What concentration did they give me for hydrogen for experiment 1? 0.001. And I'm just going to leave that as it is. And then I just solve for K. Right? We remember that? We can handle that? Okay? Now remember, when you're getting your units, see how it says include units? Remember the trick I taught you. So this is molarity squared, and this is molarity. So how many totals molarities do I have there? 3, right? So for my unit on my final answer for K, I just take away 1. So that makes it what? N squared, and raise it to the negative 1 times whatever your time unit is, minutes to negative 1. Do we see that? Because we always put our units for K on the bottom. Got it? Got it. All right, let's go through the multiple choice and then we'll call it a day. Well, it will let me. I'm still having technical difficulties. Okay, we will try the multiple choice on another day when my computer's not frozen. Okay. All right, class is almost over anyway, so we'll call it a day there. All right.
Did you stop recording?
Oops.